Hello, my pre-calculus students. Today I'm going to start you on the introduction to the last section in Unit 11. This is the one we've been building towards since the very beginning with all of those identities, the trig identities that we're using to simplify and verify and all of that. Today we're going to actually be solving equations that involve trigonometry, and we're going to have to use all of those identities to be able to do it. So this is the final section of Unit 11. We will be doing a review and having a test afterwards. But for today, here's the intro. So you're going to, the difference with these guys is that you've got an equals something. They're equations. They've got, just like a regular equation would be, it's got an equal sign in it, and you have to solve for x. That's our goal. Now, a couple things to keep in mind. First thing is watch the directions. This one says your answers are between 0 and 360. And you're going to need this chart to be able to help us to be able to solve these. So I'll include that as I download the notes and such. But you probably have about 3 or 4 copies of this at this point. All right, here's the first one, number 1. Our job is to solve for x, so I need to get the trig function by itself. Well, that means the first thing I'm going to do is move the square root of 3 to the other side. That gives me 2 cosine of x equals a negative square root of 3. And then I want the cosine of x by itself, so I've got to divide by the 2. So now I'm going to take that 2, divide it on the other side of the equal sign. You're treating it just like it would be any other type of equation. Just happens to have a trig function in it. And so I look at that and I'm like, oh, that's really cool. That's square root of 3 over 2, negative. And I know that that's on my chart. So I'm going to take my chart and I want to know where is the cosine, a negative square root of 3 over 2. So I go down my list. Here it is. I go across to 150. If I take 150, and again, I'm going to either use the radian measure or I'm going to use the degree measure. But in this case, because the directions said to keep it between 0 and 360, I know that I'm using the degrees. So my one answer is 150. X equals 150 degrees. But wait, there's more. Because if I keep going down the cosine column, I see that there's another place at 210 that I also get an answer that's negative square root of 3 over 2. So I also have an answer that it also could be 210 degrees. And so I have just solved that. I figured out the two angles that if I put that 150 or I put the 210 into this equation, I'm going to get an answer that comes out to be 0. All right, now are they all going to be that simple? And the answer is absolutely not. So let's go to number 2. Number 2 says 3 sine squared x plus 1 minus the cosine squared x equals 2. And the first thing that I have a problem with is that they're different trig functions. One's sine, one's cosine. So there's got to be some way that I can put them into being the same trig function. So I'm looking for ways that I can turn them all into sines, or I can turn them all into cosines. So in this case, if I look at it and I think about it, this right here is one of your Pythagorean identities. So I know that 1 minus the cosine squared of x is actually equal to the sine squared x. So you're looking for where you can apply those identities. That's the only thing I'm going to change for now. I'm going to keep everything else the same and see what happens. And I'm ready to do a happy dance again because I have 3 sine squareds and I'm adding one more to it. So now I have 4 sine squareds of x equals 2. I want to solve for the trig function, so I'm going to get the sine by itself. That means I'm going to divide by the 4. And that gives me the sine squared x equals 2 over 4. But I want to know what the sine is, not the square, so I'm going to square root it. Now I know I can turn this into 1/2, but you'll see why I didn't do that necessarily in this particular problem in just 1 second. Here comes square rooty. That means that it's going to be the sine of x equals a plus or minus. Square rooty has to have plus or minus. Square root of 2 is the square root of 2, and the square root of 4 is 2. What I just did by not changing this to 1/2 saved me from having to rationalize it, because I would have had 1 over 2, then I would have had to multiply by the square root of 2 over 2, and that would have given me the same answer, but I just did it in less steps. All right, so now I'm ready to figure out my answers. Again, my directions say my answers need to be between 0 and 360. And so I'm going over my chart, sine. I want to know, where is the sign a positive or negative square root of 2 over 2? And my answer needs to be in degrees. So the first place I see is 45. I'm going to keep going down. The next place I see is 135. Going to keep going down. The next place I see is 225. And the last place is 315. And so all of those are valid answers for this particular question. So let's write them down. 45, 135, 225, and 315. Okay. Next set, they're going to tell us that they want our answers still in degrees. And again, you'll see on the flip math video that sometimes he does them in radians as well. So again, it's just a matter of what part of the column, what columns you're looking for in your on your chart. The actual math of this doesn't change. All right, I have cosine here, I have cosine there. Everybody's cosine, which is great. So I don't have to change up. I don't have different trig functions like I did back in that last guy. I'm just going to combine like pieces. I have 11 cosines here. I have 4 cosines here. If I subtract 4 from 11, now I have 7 cosines. This 10, if I bring it over to the other side, 10, it turns positive. With the negative 4 becomes a 6. And so what I have this time is the cosine of x equals 6 over 7. And I go to my handy dandy chart and I say, whoa, I have nothing there that is a 6 over 7. So this guy is not on your chart, and there's got to be a different way that I can solve it. And it actually is something that we learned back in one of the other sections that we've done here. So actually I think it might have been in the last unit. What you want to do is you want to convert this to a decimal. 6 divided by 7. So I'm going to take my calculator, and the first thing I want to know is what's 6 divided by 7? And I get 0.857. See if you can see that. There you go, 0.857. Just rounded to a few places. So now I really have the cosine of x equals 0.857. Do you remember how you can figure out what x is? Some of you say, yeah, I remember. Some of you are like, I have no idea. So here's what you do. You take second cosine and put in 0.857. Now also make sure that your mode is in degrees so that you can get the right answer. So mine is in degrees, and here I go. It's 31.02. That's close enough to 31. We're going to keep it 31. Remember, we've seen these before. If it's 31.4, then you're going to keep the 31.4. But this one, because it's so close to 31, we're just going to use 31. All right, so my reference angle, x, is 31 degrees. But you're not done yet, because now you have to figure out where they're positive and where they're negative. So I go back here, this was a positive 6/7. So I'm thinking about where is cosine positive, which quadrants. So I go around, remember all students take calculus. We made a chart of all these things. So cosine is positive in quadrant 1, everybody's positive in quadrant 1. All students take calculus, and quadrant 4. Now you've got the chart that you can go back to and look at for those, but that was also talked about in a previous section. All right, so quadrant 1. The angle is the same as what the reference angle is, so it's 31 degrees. In quadrant 4, it is 360 minus my reference angle, and that gives me an answer that's 329. And so those are my two answers, 31 degrees and 329. Now just as a reminder, if you happen to have to go into quadrant 2, it's 180 minus your reference angle. And if you have to go into quadrant 3, it's 180 plus your reference angle. All right, so kind of back to those lessons that we learned back in, I think it was Unit 9 actually, that we did those. All right, so here comes the next one, the next challenge. And the next challenge, this one's going to take us some doing. This one's a little bit long. So I see that I've got tangent and I've got another tangent, but one's squared and one's not, so I can't combine them together. So what I'm going to do with this guy is think about pulling everything to the same side. 6 tangent squared x minus 7 tangent of x minus 3 when I bring that over equals 0. And you see how I've set it up? There's a squared term, there's a regular term, and then there's a number. And so what I'm going to do is I'm going to kind of go off to the side here, and I'm going to think factoring for this one. So if I think about factoring, I'm going to change my color. This would be the same thing as 6x squared minus 7x minus 3 equals 0. So if I'm thinking factoring for this, that's kind of back in the day of our algebra. Same idea, except instead of an x, I have a trig function. I've got tangent. But let's go over here to the easier one, and let's see if we can factor this. AC method, right? So first times the last is negative 18. I need the factors of 18 that add up to be a negative 7, negative 9 and 2. I need to divide by the leading coefficient. Don't forget that. Negative 3 over 2. And then I put it together bottom to top. So this is 2x minus 3. This is 3x plus 1. And I've just factored the algebra guy. But I'm going to apply the exact same thing to the problem that I have at hand. This would factor the exact same way. So this first grouping is going to be a 2, but instead of x, it's a tangent of x minus 3, and a 3 tangent of x plus 1 equals 0. And then I'm going to solve them just like I normally would. So this would be 2 tangent of x minus 3 equals 0. This guy's going to be a 3 tangent of x plus 1 equals 0. Let's do one at a time here. If I bring the 3 to the other side, that gives me 2 tangent of x equals 3. Divide by 2. Tangent of x is 3 halves. If I come over to this guy and do the same thing, 1 goes to the other side. 3 tangent of x equals a negative 1. So the tangent of x equals a negative 1/3. Now it would be awesome if 3 halves and negative 1/3 were on this chart, but they're not. So I need to do the same thing I did back in number 3, and I need to figure out where this would happen. So I've got to find the reference angle first and then put it into the appropriate quadrants for where tangent is positive or where tangent is negative. So remember, we're going to think about the all students take calculus. That's going to help us figure out where they're positive and negative. We'll do that just in a minute. But I need to know the reference angles first. So to get this reference angle, I'm going to do tangent to the negative 1 in your calculator of 3 over 2. And this one I'm going to do tangent to the negative 1 of, we don't put in the negative, that's just telling me the quadrant. So I'm just putting in a 1/3. All right, back to my calculator. I make sure that I'm in degree mode. And I'm doing second tan of 3, it helps if you turn it on, right? Second tan of 3 divided by 2. It tells me it's 56.3. So this guy equals a 56.3 reference angle. This guy, 1/3 second tan. Again, it's just the positive. I get 18.4. All right, now let's apply them to the right quadrants. So this is a positive 3 halves. If it's a positive 3 halves, they're all positive in the first, so I'm going to put this guy in the first. Tangent is positive also. All students take tangent in the third. Well, since I'm here, I might as well go over here to this guy, 18.4, but it's a negative 1/3. So now I want to put it where it's negative. Negative would be, can't be here because they're all positive, the second quadrant, positive in the third, negative in the fourth. All right, so I'm taking 56.3 in the first quadrant, it stays the same. In the second quadrant, in the third quadrant, it's 180 plus 56.3. So if you add them up, you get 236.3 degrees. So there are your two answers for that part. This 18.4 in the second is going to be 180 minus 18.4, and that gives me a 161.6. In the fourth quadrant, it's 360 minus 18.4, and that gives me a 341.6. So if they're not on your chart, you've got to go back and do the -1 thing with your fractions and then come up with the reference angle and place it in the appropriate quadrant based off of all students take calculus. All right, last one. This one says find all of the solutions. That only comes in at the end when you go to do your answer. So the way that we approach this problem is the same exact way we approach the other ones. It's just at the end when we do our answer, we're going to do it a little bit differently because they didn't give us bounds like they did here. They said only give us the answers that are between 0 and 360. This one is saying I want every answer you can possibly have for this, where that would be a true statement. So I'm looking, I want the same trig functions and I have it. That makes me happy. I'm going to put everything on the same side of the equal sign. This is going to give me a 2 cosine squared x minus a cosine of x minus 1 equals 0. And again, I'm going to think factoring for this like I did back in number 4. This would be the same thing as if I had 2x squared, 2 cosine squared, minus x minus 1 equals 0. And so if I AC method this one, 2 times negative 1 is a negative 2. Factors of negative 2 that give you negative 1 when you add them up. Divide by the leading coefficient. Simplify, bottom to top, x minus 1, 2x plus 1. And now apply that to the trig function that we have at hand. And the trig function we have is cosines. So my grouping is going to be a cosine of x minus 1 for this guy, and a 2 cosine of x plus 1 for the second one. 2 cosine of x plus 1. I'm going to take and solve them, set them each equal to 0, and solve them for the trig function. Cosine minus 1 equals 0. 2 cosine of x plus 1 equals 0. Swing the 1 to the other side. Cool, it's solved. Swing the 1 to the other side. Divide by 2. Now this one makes me kind of happy because this one is on our chart, right? We've got 1s on our chart, we've got 1/2s on our chart. So we can go to our handy dandy chart to get this. We don't have to do the extra steps of figuring out reference angles. So I want to know, where's the cosine 1? Well, the cosine is 1 at 0 and 360 degrees. Is it 1 anywhere else? No. So I have 2 answers for this. Here it is. X equals 0 degrees and x equals 360 degrees. Now let me go over and solve the other part, and then we'll talk about how you deal with this all solution thing. Cosine is negative 1/2. Negative 1/2 at 120 and at 240. So they're the 2 I'm going to put down for this guy. X equals 120 and 240. All right, so here's the story with all possibles. Remember how these graphs are like waves, and the wave keeps continuing over and over and over again. It's the same wave. It's got the same height. It's got the same period, whatever that might be when we were graphing them, but it's got the same wave. So the answer is going to repeat itself multitudes of times. So what I mean is, remember let's just look at the sine graph real quick. If I just do this, how many times does it equal 1? It equals 1 there, it equals 1 there, it equals 1 there, and it would equal 1 1,000,000 times, right? Because it keeps repeating the same exact wave over and over and over again. So this one's saying that you got 0 degrees for the cosine. Where is it going to be for the next time that it hits that same place? And it's really pretty simple. Here's the basic rule. If you are sine or its friend cosecant, they repeat themselves. Think of the period of the graph. When we were graphing them, it took 2 pi or 360, 2 pi and 360 are the same thing, to get to the next place, to get to the next time that it actually equals that value. If you were the cosine or the secant, their period was also 2 pi, 360 degrees. And then the tangent and cotangent were a little bit different. If you remember, they were skinny. It only took half as much to make that graph. So the period for those guys is 180. And all you need to do in the end is look at the trig function you have, and then you're going to add on any multiple, 360n. I think they might use k in the flip math video, but I've always seen it as n, so we're going to keep it as n's. So in other words, all I need to do is take my answer, the 0 degrees that I got, cosine repeats every 360 degrees, So all I need to do is attach a plus 360n plus 360n. This guy's still cosine, plus 360n plus 360n. So if you have a function that is sine, cosecant, cosine, or secant, you're adding plus 360n's. If you have a tangent or cotangent, you're adding plus 180n's. I do believe that in the flip math video there was a tangent problem and he was adding on 360s to it. I want to say that I would prefer that you do the 180s because it really is based off the period of the graph, and that's where the multiples happen, is whatever the period of the graph is. So again, sine, cosecant, cosine, secant are all plus 360n's because that's the period of those graphs. Tangent, cotangent, plus 180n's. Alrighty, that gives you a flavor for an introduction into this next section. So you're going to watch the flip math video, and then I'm going to do some practice examples with you like we've been doing. But email me if you have any questions or problems, and I hope you're all doing well. I'll talk to you soon. Bye.